Okay, so Algebra 2 Lesson 4 about literal equations. So the goals of this lesson are to solve literal equations for a specific variable. We'll talk about that more later. And to use them to solve real-world problems. Use those literal equations. So words to know. Coming up down here at the bottom, I really wish you would pause the video, try to answer those. If you don't get it, come back and get the answers to them. Okay, hopefully you tried. A, an equation containing more than one variable. That is a literal equation. Examples of literal equations are temperature conversion, interest rate, a linear equation has an x and a y. Those are all literal equations. B, the rules that allow the balancing, manipulation, and solving of equations. The addition property of equality states, blah, blah, blah. Those are properties of equality. Anything I do to one side must do to the other type situation. C, a rule or relationship between quantities that is written as an equation. Well, that's a formula. So formulas like y equals mx plus b. That's a formula. Rate times time equals distance. That's a formula, the distance formula. D, to take the place of or to replace. To substitute. Change it out. Substitute. If I'm not doing the video and somebody's doing it in my place, that's a substitute teacher for the day. E, equations that have the same solution set and can be formed from one another using the properties of equality. Those are equivalent equations. Equivalent equations. All right, as we go. First example. This is a literal equation. It is the circumference of a circle. 2 times pi times r. So, in the circle, in the circumference, 2 pi inches, we're going to say that r is 1. If I had, and here's how I solved that, because I had 2 pi r and I divided by 2 pi on each side to get r is 1. Same thing here, next problem. If c equals 5 inches, find r. Well, if I divide both sides here by 2 pi r, because that's the part of this over here that would allow me to isolate r, then 5 divided by 2 is 2.5. That's the radius. Keep on going down here. If I have the circumference equals 10 inches, so this is where that 10 inches is going to go. And I'm solving for r, so I want to divide by 2 pi. And I find out that the radius here is 5. Sorry, I didn't fill this in. Okay. That's one example. So when we talk about a literal equation contains more than one variable, and all formulas are literal equations. For example, the perimeter of a rectangle is 2 lengths plus 2 widths. The area of a triangle is 1/2 of the base in height. X plus y equals z. That's formula. Nothing in particular. You just call it the formula to your bank account and your husband's bank account, how much money you got all together. You know, 2b minus 5 equals c. 2 variables. Formula. On to the next section. Solving a formula for a variable. basically means rewriting the formula, okay? So let's go back and look at this C equals 2 pi r. So I want to solve this for r to form an equivalent equation. Now, I want this by itself. So I divide everything by 2 pi, and I wind up with the circumference divided by 2 pi is equal to r. Once I've got that rewritten, okay, it's pretty simple at that point to know how to work these problems. In this example, if the circumference is 8 pi, well, what's 8 pi divided by 2 pi is 4, which means the radius is 4. Solving for the radius here. If I know that the circumference is 15, then 15 divided by 2 pi gives me the radius of 7.5 divided by pi. I can't divide 15 nothing by 2 pi, okay? Here the circumference is 24, so 24 divided by 2 pi is going to leave me 12 over pi, which is my answer for the radius. We're going to leave things in terms of pi a lot, all right? Solving a formula for a variable, use the properties of equality to solve for a variable. This one asks us to solve the equation for W. Now here's W over here all by itself. So the first step was to simplify this 2 times 5 and get 10. To get to here, they took the 10 from both sides using a property of equality. Then to get to this, they divided both sides by 2. So this next one says solve the perimeter formula. This is a formula for W. 2 times the length plus 2 times the width. So I want to isolate this W. The first thing I need to move is move that 2 times the length to the other side. Now I've got it equaling 2W. Then all of this divided by 2, that would knock this out, leave you P minus 2L divided by 2. And that's what W is equal. If you want to enter that formula horizontally in a calculator, you're going to need to put the top of this fraction in parentheses, like that, then divided by what's on the bottom. If there was more, you'd put parentheses around that if you needed to. And then you could just stick the whole thing in your equation, in your calculator. I'm going to hurry this up a little bit. Sorry it's taking so long. So, equivalent forms of an equation. Rewrite 1/2 3 different ways. So this just shows you that just because it's written differently as a different type of problem doesn't mean it's not equal, okay? If I want to rewrite this 3 different ways, I would look at, I've got the W equals P minus 21 over 2. That's what we'll start with. But then I could split it up to be P divided by 2 minus 2 times the length divided by 2. Same thing. Or P over 2 minus the length would give me the same thing over here. Because what's 2 divided by 2 is actually 1, right? So that would cancel that out. When we want to solve a problem, and we know a few things, right? We solve for the variable W, because that's what the width of the rectangle, that's what I'm looking for. So I take this, subtract P minus 22L, plus 2, and then that'll equal 2W, divide both sides by 2, and this is my rewritten version. Then I put in what I know. I substitute in the known values here. Well, what do I know? I know the perimeter is 17. I know the length is 5. Now if I simplify this down to 17 minus 10, divided by 2, or 7 divided by 2, we find the width to be 3.5. Next part of this is we're going to solve a formula for a variable. So this formula converts Fahrenheit to Celsius. So Celsius is equal to 5/9 of the Fahrenheit temperature minus 32. So I want you to solve this formula for F. Now this is highly used in science, okay? You know, if you don't understand Celsius, you can plug in the Fahrenheit temperature that you do know, because most of our gauges are in Fahrenheit, okay? So as a start here, the first thing I want to do is multiply both sides by the reciprocal of 5/9, which is 9/5. Then that leaves me, this is now gone, that makes 1, Fahrenheit minus 32. I add that 32 to both sides to find out that the Fahrenheit is 9/5 of the Celsius plus 32. As we write literal equations in different ways, we see what's going on there. Another thing here is if I wanted to say 32 5/9 and distribute that in here, 9 times 32 is 160. Can do that. Different ways to rewrite it. We got the same result. We're using two different methods. So the route that you take doesn't matter as long as you use the properties of equality. Whatever I do to one side, I must do to the other. So we're going to solve a literal equation. Where'd that page go? Hold on. Got ahead of myself. So sorry. Okay. So when we solve a literal equation, the process is the same. Whether you're dealing with numbers or variables, variables, remember, are just numbers whose values are not known yet. Working on knowing what they're worth. And when solving a literal equation, sometimes simplifications can be done in the whole process. So, right here, let's go. I've got 5x minus 3 equals 2x. So, if I add this 3 to both sides, there it is. It's gone from here now. I moved it. And then if I subtract this 2x from both sides, it's gone from here. I moved it over there. So now I combine 5 minus 2, x, to get 3x equals 3. Divide both sides right here by 3 to find out that x equals 1. How about this one? It says solve for x. So I need to combine like terms to get the x's together, add the b to both sides to move it over, subtract the cx. Then I've got a minus c equals times x equals b. Well, I can't do anything about that a and c, but I can divide by this x to move it. What did it say? Solve for x. Not bad. Should have divided by the a and c. See, sometimes you got to pay attention here. A minus c. That's what I'm dividing by. Because I want to solve for x, not this. I will get rid of that. So x is equal to b divided by a minus c. All right. Using a literal equation to get a solution. So we're going to solve first this literal equation for x. Okay? So we've got this negative f plus gx. We want to move the gx over, right? Which is going to leave me dx minus gx equals negative f. Then I want to divide both sides by the d minus g. So that's f on top divided by d. When I make that up, I apologize, guys. Okay, negative f divided by d over g. So then we can solve for this when d is 5, f is 2, and g is 4. We just substitute in the values. Negative 2 divided by 1, which leaves x to equal negative 2. Not hard stuff, is it? All right, one more. Let's get back to this. We're going to solve a literal equation for a. So I want to get this down. First, here's my a value. Need it by itself. So I need to add 8b to both sides. That takes it away from here and gives it to me here with this 6c. Then I need to divide both sides of that by 2. This cancels, and that's what I'm left with. So as I'm looking at this, they've split this up to be, they've factored out this 6c and 8b, divided it by 2, then divided the whole thing by 2, as up here, canceled that out, and came up with this simplified version of a equals 3c plus 4b, or a equals 4b plus 3c, however you want to look at it. Those are interchangeable because of that property of addition. No matter what order I add them in, I get the same answer. Okay, so review a little bit here before we close it. First of all, what operations and property of equality can be used to solve a blank equation for a given variable? How about the inverse? If it's subtracted, you add it to both sides. If it's multiplied, you divide it on both sides. And we've been studying literal equations here, so that's what we're using inverse operations to solve. Solving a literal equation for a variable results in the variable being equal to an expression. Just rewriting, that's what that means. When I take distance equals rate times time. Distance equals rate times time. And I divide both sides of that by time. So what I get left here is that the rate you go is equal to the distance you travel in the time you travel it. That's what that means. You don't get a value for rate, you get an expression for rate. So then the expression can be evaluated if the values of all the other variables are known. Okay, you have practice with the assignment, 4 questions, you have quiz, same old, this is what we're working on, is getting in a routine, do the same thing for each lesson, so there's no, and don't forget to let Miss Lutz or myself check off your completed notes, the guided notes. That's worth 9, that's 20% of each lesson, 9 points out of 45, 20%. Of the lesson is whether you filled out those guided notes or not. Okay, guys, see you at the next video.